All right, let's get right into it. Today we're going to break down a paper that, honestly, changed the game for autonomous AI, Toolformer. This isn't just another story about making models bigger. No, this is about making them smarter. It's about how researchers taught a language model to give itself hands to actually interact with the digital world. So, let's dive in and see how they pulled it off. So, the whole thing kicks off with this really powerful question. What if an AI could go beyond just predicting the next word? What if it could actually learn to use tools? A calculator, a search engine, all by itself, without a human having to spoon-feed it every single instruction. That right there, that's the core challenge this paper decided to tackle. Now, to really get why Toolformer was such a huge deal, we got to rewind the clock a little bit. Think back to late 2022, early 2023. We had these massive language models that seemed all-powerful, but if you actually tried to use them for anything serious, you'd hit a wall, fast. You'd run into some really frustrating and, frankly, sometimes hilarious problems. And look, we're not talking about small glitches here. You can't have an autonomous agent that just makes stuff up, or that can't do third-grade math, or has no idea what year it is. These were fundamental flaws holding everything back. And just making the models bigger and bigger, well, that wasn't fixing the problem. We needed a totally new way of thinking. And this brings us to the single most brilliant idea in the entire paper. The authors basically said, okay, instead of spending a fortune on human-labeled data to teach a model how to use tools, what if the model could just teach itself? Could it figure out on its own when a tool would have been helpful and then create its own training examples? This is the key concept. It's called self-supervised learning. And honestly, the best way to think about it is like you're studying for a test. You try to solve a practice problem, then you check the answer in the back of the book. If seeing that answer gives you an aha moment and helps you understand, you remember that technique. If it just confuses you more, you ignore it. Toolformer does that exact same thing, but for using software tools. So how does this self-teaching engine actually work under the hood? Well, the researchers came up with this incredibly slick three-step process that lets the model generate, test, and filter its own examples of how to use tools. This three-step dance is really the heart of the whole thing. First, the model plows through a mountain of text and just guesses. It says, hey, maybe a tool would have been useful right here, and it spits out tons of potential API calls. Second, it actually runs all of them. And third, this is the magic part, it filters out all the bad guesses. And that filtering step is the secret sauce. The model has a way to measure its own confusion about what text should come next. So it measures its confusion without the tool's help, and then it measures it again with the tool's result plugged in. If the tool's answer makes it less confused, if it makes the future clearer, ding, 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 it tweaks that example. It's a beautiful, self-improving feedback loop. Let's make this real. The model sees a sentence like this. It spots the numbers and thinks, maybe some math is supposed to happen here. So it tries out an API call to the calculator. The calculator returns 0.29. Suddenly, predicting the rest of the sentence, 29% pass the test, becomes way, way easier. Its confusion drops, and so the model says, yep, that was a good call, and saves it as a lesson for the future. Here's another great one. The model is writing a sentence and realizes it's missing a key fact, so it learns to pause, form a question, and send it to a Q&A tool. The tool sends back the answer, Massachusetts Medical Society, and bam, the model can now perfectly complete the sentence. It is literally learning to fill in its own knowledge gaps on the fly. And this example is huge. The model sees a term it doesn't know, the Brown Act. The old way was to just guess, to hallucinate. But Toolformer learns to say, hold on, I should look that up. It queries a search engine, gets a real definition, and then weaves that factual information right into what it's writing. This is how you build an AI that's actually grounded in reality. Okay, so the theory is elegant, it's clever, but did it actually work? This is where the paper gets really exciting. The researchers didn't just talk the talk, they put their little model up against the biggest heavyweight champion of the time. And the matchup was almost comical. In one corner, you had Toolformer, built on a 6.7 billion parameter model. In the other corner, you had the behemoth GPT-3, clocking in at 175 billion parameters. That's over 25 times larger. This was a classic David versus Goliath showdown. And the results? They were just staggering. On math word problems, the giant GPT-3 totally stumbled, scoring a measly 14. Toolformer, our little underdog with its simple calculator tool, it scored over 40. That's not just an improvement, that's a knockout. It proved without a doubt that having the right tool is way better than just having brute force. And it wasn't a one-time fluke. The exact same thing happened on tests of factual knowledge. The little 6.7 billion parameter Toolformer, just by learning how to use a Q&A tool, consistently outperformed the 175 billion parameter GPT-3. The takeaway was crystal clear. It's better to know how to find an answer than to try and memorize everything. So what's the big picture here? Why should a developer building agents today still care about this paper? Because Toolformer didn't just build a model. It gave us the fundamental blueprint for almost all the agentic AI systems that have come since. At the end of the day, this paper's biggest contribution was proving that this whole self-teaching thing was possible. It created the core pattern, let the model decide when to use a tool, what to ask, and how to use the answer. You can draw a straight line from this idea to modern frameworks like Langchain and the whole concept of AI plugin stores. It shifted the goal from make an AI that knows everything to make an AI that knows how to find anything. Now, the model wasn't perfect, and the authors were really clear about that. It couldn't chain tools together, search for a number and then pass that number to the calculator. It wasn't interactive, so it couldn't browse a few search results. But these weren't failures. They were basically the roadmap for the next wave of research for the entire field to solve. Okay, that brings us to our final thought for today. We're going to take the core idea from this paper and push it just one step further into the future. Toolformer showed that an AI can teach itself to use the tools we give it. But what comes next? Imagine this. An agent gets a task, but it doesn't have the right tool for the job. Instead of just giving up, it recognizes a pattern in its failures. It thinks, you know what? I keep getting stuck trying to convert these file formats. So it pauses, writes a quick little script to do the conversion, tests it, and then adds that script to its own library as a new tool it can call in the future. That would be a system that doesn't just learn, it evolves. It actively expands its own capabilities. And that's the trajectory that a paper like Toolformer really put us on. This is for entertainment purposes only.